welcome to the next session on finite element analysis. In this session, we are going to discuss about the element types in FEA. In FEA, elements are the fundamental building blocks used to discretize and approximate the geometry of a physical structure or component. Different types of elements are employed based on the characteristics of the problem being analyzed. We are going to discuss about the various elements henceforth. One-dimensional element, it is called as 1D element. The first one is called as rod or truss element, represented by two nodes and are suitable for modeling structures where deformation primarily occurs along one axis. So here you can see this is a rod element and these are the two nodes on the two ends. This is a 1D element. Here you can see this is a truss element. So each element that you see, this is the first element, second element and the third element. As you can see, it is marked. The first element is between node 1, 2. Second element is between node 1, 3. And third is between node 2, 3. So you can see this represented by two nodes and this is a one-dimensional deformation that you can see. Two-dimensional elements, it is called as 2D element. The first type in this is called as a triangular element, defined by three nodes and commonly used for modeling curved surfaces or irregular geometries. This is the first order element where you have three nodes, 1, 2, 3. So this is called as T3 element. In the second one, you can see it is 1, 2, 3, 4, 5, 6. 6 nodes. So this is called as second order element, T6 element. Both of them are triangular element because they look like a triangle. Quadrilateral element defined by four nodes and are often used for simpler rectangular or square geometries. So this is a quadrilateral element. You can see this is 4-noded quadrilateral. This is called as 8-noded quadrilateral because there are 8 nodes over here. This is a 9-noded quadrilateral. These 4 triangular elements. So these 3 is what you need to focus on. These are the quadrilateral elements. Now here you will read that there are 4 nodes. So 4 is a basic nodes required. It can have more nodes to define the quadrilateral. The third type of three-dimensional element is called as tetrahedral element, defined by. Next we'll talk about the three-dimensional element. One of them is tetrahedral element, defined by 4 nodes and are suitable for modeling irregular 3D geometries. You can see here 1, 2, 3 and this is the 4th node that you have here. There are 4 nodes basically. The next type of three-dimensional element is called as hexahedral or brick element. It is defined by 8 nodes and are commonly used for modeling regular 3D geometries. So this is the brick shape. You can see there are 8 nodes here. Third type of 3D element is called as wedge element, defined by 6 nodes and are useful for modeling geometric transitions between tetrahedral and hexagonal regions. So you can see 1, 2, 3, 4, 5, 6. These are the 6 nodes which are defining this wedge shape element. The next type of element which you see in FEA is called as axisymmetric element. It is used for modeling axisymmetric geometries, reducing the 3D problem to a 2D axisymmetric element. What happens is you can basically draw a 2D body and with the help of this axisymmetric effect in FEA, you will make this revolve kind of feature and you can see this 3D element. But whenever you go to geometry, you will still find that it is 2D type. Similar thing applies for this pressure vessel which is created here. I have created some analysis based on this axisymmetric element. You can go through them. It will help you understand what is the meaning of axisymmetric. Though the geometry remains 2D, you get an effect of 3D to understand what would be the effect had it been a 3D body. This is a torus kind of effect created. The next element is called as beam element. It is ideal for modeling slender structures such as beams or columns they are defined by nodes at each end. So you can see here, this is node 1 and 2. This is a beam element. Shell elements used for modeling thin structures like plates or shells. They have two surfaces and are often defined by 3 or 4 nodes. So you can see here, these are the 4 nodes and this is a shell element. You must have used the shell option or the shell command which is present in SolidWorks. It is basically used to create a very thin boundary to a particular solid body. So this is another type of element in FEA. The next type of element is called as special element. In that, the first one is called as a spring element. It represents the linear springs and are useful for modeling simple elastic connections. So this is your spring element, which you can see here. This technique is what we have used while solving the direct application of EME problems as well, where we were creating an analogy between the FE numericals and the electrical system, and we were trying to convert every system into an electrical system. So that's where we have used the spring element particularly. The next one is called as rigid element. It is used to connect nodes together and enforce rigid body motion or connectivity. So any two spring elements is also connected by a rigid element. That's very simple to understand. So this is a rigid element that you see. This can also be called as the sides of a element. Mixed elements combine different element types in a single model to better represent complex geometries or material behavior. So basically, when you make use of more than one type of element, when you're analyzing an FEA problem, you say that you are using mixed elements to solve. Say in a particular zone, your body is of a regular shape, so you can go for quadrilateral element. When you have irregular shape bodies, you can go for tetrahedrals. So you are basically using two different types of elements to define your system. Next is called as the fluid elements. It is used in fluid dynamic simulation to model the behavior of fluids within a defined domain. So suppose that this is a pipe and there is water flowing through it, and we are trying to analyze the effect of flow of water through a pipe. So then this element will now be called as a fluid element, which is contained by the surface of the pipe. So this fluid element is basically used for analysis in CFD part. It is not used in any other type of modules in FEA. Next, we'll talk about the contact elements. It is used to model interactions and contact between different parts of a structure. They help simulate contact, friction, and separation. So you can see here when two bodies are in contact, that's when you go for contact elements. There could be some friction between the two bodies, or there could be a separation between the two bodies. So you can use contact elements whenever two elements are supposed to be closer to each other in a field. Lastly, we'll talk about the key points or the takeaways from this lecture. Each type of element has its advantages and limitations, and the choice depends on the nature of problem, the geometry of the structure, and the accuracy required for the analysis. Engineers and analysts need to carefully select and mesh elements to ensure that the finite element model accurately represents the physical behavior of the system being analyzed. So whenever you are analyzing, you need to choose the type of element that is required for a particular problem such that you are able to mesh the body properly and you are able to obtain better solutions which are converging towards the exact one. So with this, I end the session. I hope you have understood the lecture. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.